Okay, another practical issue. What if x only takes on two values, 0 and 1? Well, we have a special name for that type of variable. We call it a dummy variable, or sometimes we call it an indicator variable. And there's no problem at all in that. There's nothing in our assumptions that rule this out. Okay, so there's that is not a problem for estimating a linear regression, and in fact, dummy variables can be quite useful. Okay, the pictures will look a little different. I'll show you a picture in a second. Okay, here's what I mean. So if our x variable only takes on values 0 and 1, then we sort of don't have this nice cloud of data. We just have these two, but nothing wrong with that, right? Okay, and then we estimate, then sort of beta naught hat is interpreted as the sort of mean of the group of observations that have the dummy variable equaling 0, and beta 1 hat is the sort of increment in the mean, or the sort of effect of having the dummy variable equal 1. Okay, so dummy variables serve a number of important roles in linear models, and we've actually seen one already, randomized controlled trials. So when Esther was talking about having sort of two groups, a treatment and a control group, we could just simply have done the whole analysis in the linear regression framework, assigning a 0 to one of the groups and a 1 to the other group. Okay? So suppose we have some treatment in whose effect we're interested. We randomly assign the treatment to half of the observations, leave the other half untreated. We assign the treated observations x equals 1, and the untreated x equals 0. Okay? And then if we estimate the regression above, beta 1 hat will be the estimated effect of the treatment. And by the way, x need not be randomly assigned half zeros and half ones or anything like that to be a dummy variable. So we do use dummy variables, or can use dummy variables, if we do have this sort of random assignment variable, but we can use it for lots of other things too. Any characteristic of the observations that exists on some but not all observations can be represented with a dummy variable. Okay? So there's nothing about a dummy variable we're assuming is randomly assigned or anything like that. Okay, and we'll see lots of other uses of dummy variables when we get to multiple regression, because we can use them to sort of multiply, we can use them to interact with other explanatory variables and shift slopes around and trace out nonlinear relationships. We can do all kinds of tricky things with dummy variables, and we'll see that later. Okay. Another sort of practical issue that we'll sort of deal with in more detail in multiple regression. You might be thinking, well, fine, the linear model seems pretty useful. We can use it for all kinds of stuff. But isn't it really restrictive? I mean, maybe the relationship between these variables, there is a relationship, but it's just not linear. And so we're sort of imposing linearity on here. And that seems like something we wouldn't often want to do. Well, there are a couple things I can say about this. One is that the linear model is actually super flexible. Okay? So for instance, we can take nonlinear functions of both of the variables, x variable and y variable, and sort of analyze those, the sort of relationships between those nonlinear functions of x and y within a linear framework. We can also create interaction variables, which is sort of the product of two variables, and that allows for, sort of other types of nonlinearity. And we can do all of this, and like I said, we can use dummy variables to sort of allow for nonlinear, allow for sort of nonlinear shapes by sort of, tricky multiplication. We'll show you examples of that. But the point I want to make now is just that this is actually, it seems like it might be a restrictive framework. It's actually a super flexible framework. And we'll see all kinds of examples about how flexible the linear framework actually is. One additional comment I want to make about this is that we can do the non-parametric version of a linear regression that Esther talked about last time, a kernel regression. And researchers do they do estimate kernel regressions, and they're useful in a lot of situations, but there are serious trade-offs, and there are very good reasons why the linear regression is the workhorse that it is. And the trade-offs mostly come in the form of efficiency. A linear regression is going to be a much, much more efficient way to estimate a relationship than a kernel regression. So the kernel regression is sort of infinitely flexible in some sense, but you pay for it because it's not an efficient estimator at all, really.